Hello everyone, welcome back to ATB Mathfocus. Today we are going to dive into our next topic as part of trigonometry, which is the sine rule. We use the sine rule to find missing sides and missing angles on a non-right angled triangle. Last time our focus was on the right angled triangle, but we are now moving to a non-right angled triangle. So we are going to look at the sine rule and later on look at the cosine rule in the next video. Alright, so for the sine rule, given our triangle with the three angles and angles, right? So it's a non-right angle triangle. So on this non-right angle triangle, I'm going to give some letters to the angles and the sides of this triangle. For instance, let's call this A, this B, and this C. So the side that is opposite to A, we name it a small letter A. The side that is opposite to B, which is to angle B, is a small letter B. The side which is opposite to our C is a small letter C. So now that we have named the sides and the angles on our triangle, what we are going to do now is we are going to formulate a sine rule equation. So for the sine rule, it states that a small letter A, which is a side A over the sine of the angle A, is equal to the side B over the sine of an angle B, which is also equal to the side C over the sine of an angle C. So we are literally saying, if you have this side A, if you say A over the sine of this opposite angle, the corresponding angle, it becomes A over sine A. It is equal to B over sine B, which is equal to C over sine C. This formula is mainly used when you want to find the value of the side. And then if we want to find the value of the angles, suppose angle A, which is denoted by a big letter A capital letter A, capital letter B, capital letter C. Now you put this sign on top and the side on the denominator. So we are going to write this down. When we want to find the value of an angle, so this time we use sine A over A is equal to sine B over small letter b, which is equal to sine C over a small letter c. So these are our formulas for finding missing side, finding missing angle using the sine rule. So what happens is you only use two equations at a time. For example, here, suppose you have items where you are given angle A, side B, but you are not given angle B. You only use these two equations, right? You only use these two equations and you ignore the equations that include the equation that includes C. So you'll be focusing on two equations. So mainly the sine rule is used when you are given three known variables and one unknown variable, right? So what happens next is to make the one variable that you want to find a subject or formula, and then you find it. So the other thing that I want to talk about is it is not always the case that you'll be given a triangle ABC. The triangle can be PQR. The triangle can be XYZ. So you are just going to formulate your formula like this way. So I'm just going to give an example of a triangle XYZ and I name the sides so that you know what I'm really talking about. So this time we have our triangle here, and I want to name this side X, this side Y, this angle X, this angle Y, this angle Z. These are big letters. And now the side that is opposite to Y, directly opposite to Y, is a small letter y. The side that is directly opposite to X is a small letter x. The side that is directly opposite to Z is a small letter z. So if you are to write the formula or our equation of finding the missing sides, we will be saying Z, a small letter, yes, I've just decided to start with a small letter z. Small letter z is equals to sine over sine z is equal to a small letter y over sine y, which is equal to a small letter x over sine x. So this is our formula. And then similarly, when you want to find the value of the missing angle, we write our sine z over small letter z is equal to sine y over our small letter y, which is equal to sine x over our small letter x. So let us move to our first example. So on this first example, we are going to find the missing side. So let me write finding missing sides. Missing side. All right. So here we have an example. In a triangle ABC, AC is equal to 17 centimeters, angle A is equal to 105 degrees, and angle B is equal to 33 degrees. Find AB. So AB is the side that we want to find. So firstly, we have to draw up a triangle so that we plug in the values that we have and see which side is the unknown side. All right, so given this question, we have our 105 degrees. This is an obtuse angle because it is an angle greater than 90 degrees but an angle less than 180. And this is an acute angle. I once talked about this in my first video. So this is a 33-degree angle. It's an acute angle because it lies between 0 to 90 degrees. It is less than 90 degrees. So we are going to just draw a sketch diagram so that we plug in our values. So let me draw it like this. Let's take this one, this to be our 105 degrees, and I draw like this. It's just a sketch. So here we said this is our A. Let's make this our B and this our C. A, B, C. So our B is what? Is 33 degrees. We have 33 and we are not instructed to find C, so we don't mind about finding C. But if you wanted to find it, it's just the rule of a triangle that the angles in a triangle, they add up to 180 degrees. So it's supposed to be 105 plus 33 subtract from 180 to get this angle. All right, so meanwhile we are going to write our AC. Our AC is 17 centimeters. By the way, what is AC? In terms of the small letters, it's opposite to B. So our AC, so it's B, small letters B is equal to 17 centimeters. And then we are instructed to find AB. We are instructed to find AB, which is opposite to angle C. So it's a small letter C. That is the side that we want to find, our small letter C. All right, now that we have put our variables, our known variables on our diagram, we are going to move to the application of the sine rule. Okay, so if we want to use our sine rule, we are going to take the sides, the known variables, and we equate to the one with the known variable and an unknown variable. For instance, if you want to use the sine rule, there should be a one set which is complete. For example, here we have side B, we have angle B and side B. So this is our complete side. So we are just going to do this. We're just going to say B over sine B is equal to, the other one is C, our unknown side, the one that we want to find. So we put it C over sine C, which is known. All right, so this is our formula that we want to use. But right now, are you seeing this? We want to find side C, but we are not given angle C, which means we first need to find angle C. So here, angle C was important. It was vital. So we are going to first find the angle C such that we have the C to substitute our angle C here. So we said, how are we going to find our angle C? We are first going to add 105 degrees plus 33 degrees, and we get what? We get our 138, right? Now that we have our 138 degrees, to get our angle C, we are going to say 180 subtract 138 degrees. And we get 42 degrees. 42 degrees. So 42 degrees is the value of our angle C. So we are going back to our angle C and we plug in our value, which is 42 degrees. So this is the value of our angle C. So what are we going to do next? We come back to our formula. B over sine B is equal to C over sine C. So we plug in our values. Our B is what? From the diagram, our B is 17 over sine angle B, which is 33 degrees, which is equal to C, our unknown variable, over sine 42 degrees. So now we make C subject to a formula because we want to find the value of C. So what we do, we are going to multiply both sides. It's either you cross multiply or you multiply both sides. I can choose to multiply both sides by sine 42 multiplied by sine 42. So this one, it cancels, this sine 42 and sine 42. And here we have our 17. If you multiply here, it becomes 17 sine 42 degrees over our sine 33 degrees is equal to C. So we are going to punch this on our calculator. Make sure your calculator is in degree mode. You say 17 sine 42 divided by sine 33. Your answer is 20, let me write it down. The answer here, we got 20,8857. I won't write then the rest of the values because we want to round off. So if we want to round off this to one decimal place, we can write 20,9 centimeters. Remember, we are given our B in centimeters, which was AC. So here 20,9 centimeters is equal to C. So you have found the value of C, which is our AB. So you can try to attempt this question. Our second example reads, in a triangle PQR, P is equal to 78 degrees, R is equal to 38 degrees, and PR is equal to 15 centimeters. Find QR. So QR once again is our side. It's a missing side that we want to find. So the first thing, we're going to draw our diagram. We name it PQR. So this is our diagram. Since there are some acute angles, I can just simply sketch this small triangle and I name this P, Q, R. So I'm given that P, my angle P is 78, angle R is 38, then side PR is 15 centimeters. Likewise, we are going to name this side PR using a small letter for our sine rule concept. So opposite to Q, we have our small letter Q. So this side PR is also Q. And we are instructed to find side QR, which is opposite to P, so it's a small letter P. So we want to find the value of P. So like what we said earlier on, one side should be complete so that we find the other side. So we have here we have our side, one side should be complete. So we have our side Q, angle Q and side Q. Why am I saying this is complete? Because using the principle of our triangle, which says that the angles in a triangle should add up to 180 degrees. And already we are given two angles, so we can find the value of Q. Once we find the value of Q and we have the side Q, then we have one complete side. So what are we going to do first is we're going to find the value of Q. Our angle Q is equal to 180 degrees, subtract the sum of the rest of the angles, the two other angles. So we are just going to say, let me calculate. So here our calculator gives us 64. So our Q is equals to 64 degrees. So we are going to plug in our value, our 64. Now that we have our 64, our angle Q, we are now going to write our sine rule using the letters that we are given on our triangle. So we said we have a complete side, which is Q over sine Q is equal to our incomplete that we want to find, which is P over sine P. So we are going to plug in our values. Our Q is what? Is 15 over our sine 64 degrees, which is equal to P, our unknown variable, over what? Over sine 78, which is the value of our angle P. So you can substitute this. Let me also write QR so that you won't be confused. So what are we going to do? We are going to make QR or P the substitute formula. So we multiply both sides by sine 78 by sine 78. So this cancels out and this becomes 15 multiplied by sine 78 degrees over sine 64 degrees is equal to our QR or our P. So let me calculate this. Remember, it's in degree mode. 15 sine 78 over our sine 64. So our answer is 16,324,33378. So I'm just going to round it again to one decimal place. So it becomes 16,3. Remember, it's a side, so it's in centimeters. Since our Q was given in centimeters, which goes to our QR. So this is the value of our side P or our side QR. So this time we want to find missing angles, the value of a missing angle. So we have our first example, which reads, in a triangle XYZ, y is equal to 41 degrees, our side xz is equal to 11 centimeters, and yz is equal to 8 centimeters. Find angle x. So we want to find the value of the angle x. Our angle x, first we have to draw up a triangle, our sketch diagram, and we plug in the values that we have. We are given an acute angle 41 degrees, our side 11 centimeters, which is xz, our yz 8 centimeters. So I'm just going to sketch a diagram, a simple triangle. On this triangle, I say this is x, this is y, and this is z. So for our value of y, we are given 41 degrees, and we are given side xz 11 centimeters. Xz is also what? Is also small letter y, and our yz, which is 8 centimeters, which is also our small letter x. And we are instructed to find angle x. This is the angle that we want to find. This one, let me just put a question mark. So we want to find the value of the angle x. So here what you have to know is, when you want to find this angle x using the sine rule, you should know that mainly the sine rule requires you to find an angle given a side angle, where this angle is not included, is an excluded angle. So we are saying our angle here is on its own, right? Our 41 degree angle, and we have our side and another side. When I'm saying an included angle, this angle was supposed to be here if it is included, but it's an excluded. Given the values of the sides that we have and the angle, our angle is not included in between the two sides that we are given. So when you are given a side angle, you apply what? Your sine. We use the side angle side when we are to apply our cosine rule. So this time we are using side angle. All right. So for our side angle, this time we are instructed to find the angle x. So now we are going to apply our sine rule on this question to find our angle x. So to find our angle x, we have our complete side, which is side y and angle y. So we are going to write sine y over our side y is equal to the angle that we want to find, sine of an angle x over our side x. So what we're going to do is to plug in the values. So sine y is sine 41 degrees over our side y 11, which is equal to our sine x, the angle that we want to find, over our side 8. This time we are going to multiply both sides by 8 so that we make sine x a subject of formula. So multiplied by 8 multiplied by 8. What happens is this 8, it cancels out with this 8, and we move to our left side. So it becomes 8 sine 41 degrees over 11 is equal to sine x. So given that 8 sine 41 degrees over 11 is equal to sine x, what do we do to find x, the value of x? We said it earlier on that we introduce the inverse of sine. So let me write our x. X is equal to the inverse of sine, this, or like this left hand side. So it becomes 8 sine 41 degrees over 11. You're just going to punch this on your calculator. Inverse sine of 8 sine 41 over 11. Let me punch it on a calculator. my calculator is in degree mode. I write second function, sine of 8 sine 41 over 11. My answer is 28,4. Let me write it down. X is equal to 28,498,375,25 degrees. I can round it to one decimal place, so X is equal to 28,5 degrees. So this is our value of angle X, 28,5 degrees. This term our question reads, in a triangle PQR, P is equal to 8, Q is equal to 12, angle P is equal to 40 degrees. Find angle Q. So we are going to draw our diagram, and we plug in the values. We calculate the value of angle Q. So here we are going to draw this triangle. This time let us start with our P here. So P, Q, R. Opposite to P, we are given P is equal to 8. Opposite to Q, we are given Q is equal to 12. And then we are told to find, we are given P which is 40 degrees, and we are told to find the value of Q, right? So let us calculate. So first thing first, we need to check whether we have a complete side where there is an angle and a corresponding side. Yes, we have it. We have angle P and the corresponding side, small letter p. So therefore P over, no, this time we would love to write, we want to find an angle, so we put the sign on top. Sine P over P is equal to sine Q that we want to find over a small letter q. So our angle P is 40 degrees, so sine 40 degrees over 8 is equal to sine Q, the one that we want to find, over 12. So we are going to multiply both sides by 12, or in other words, not in other words, but the other method is to cross multiply. I've decided to choose to multiply both sides by 12. So here 12 cancels out with 12, and sine Q remains on the right side. So here we have our 12 sine 40 degrees over 8 is equal to sine Q. So you can choose what to do. You can punch this first, you write the decimal, and then you introduce the arc sign of the value. But I'm just going to write Q is equal to the arc sign of 12 sine 40 over 8. So punching this on a calculator in our degree mode, second function, sine of 12 sine 40 over 8. Our answer is equal to 74, so we have Q is equal to 74, 61856831. To one decimal place, our Q is equal to 74,6 degrees. So this is the value of our Q. But note that in such a question, there can be an ambiguous case where there can be two angles. So on that ambiguous case, I'm going to explain it on the next video. Make sure you follow for the next video and you see what happens when you have an ambiguous case. So for this time, you can stop here. And then I'm going to search for a question, a past examination question, so that we can do together.